Hello, and welcome to the Badger Industries webinar as part of the 7F Users Group Digital Conference. Over the next 20 minutes or so, I look forward to showcasing Badger Industries solutions for the 7FA exhaust system. As a single source provider, we can maintain your expansion joints and your ductwork between the gas turbine and the HRSG. My name is Matt Long, and I manage combined cycle operations for Badger Industries. I started my career as an application engineer for GE turbines, and since then I've been managing expansion joint sales and on-site service for about 6 years. Today we'll be talking about 3 portions of your exhaust system and Badger solutions for each: the 7FA Flex Seal area, the A042 duct, and the HRSG inlet expansion joint. Each of these relies on capable and experienced field service teams in order to meet critical deadlines and execute these projects on time. Just to make sure we're talking about the same flex seals, as I understand there's a couple different areas. We are referring to the exhaust frame exit flex seals at the trough, not the exhaust frame inlet flex seals just after the third stage buckets. So comparing that to the diagram on the right, with the flow going from left to right, we start with the exhaust flex seal area in the trough, which begins at 1 there on the bottom and of course continues all the way around the circumference. And then the next is 2, which is the A042 duct. And then number 3 is positioned just over the HRSG inlet expansion joints. So let's discuss the original flex seal design. In the diagram, you'll see the exhaust flow from right to left, and we have cut off the manifold right after the turbine for clarity. The manifold is connected to the diffuser by a series of overlapping leaf seal plates that allow the exhaust manifold to expand into the diffuser during thermal cycling. The leaf seals are bolted to the manifold on the ID and allowed to freely move and expand under a clamping bar on the OD that's connected to the diffuser trough. The leaf seal plates are mechanical seal, which is not gas tight. They are made of Inconel 718, and under simple cycle operation, the flex seal has proven to be a robust solution with a long useful life. In combined cycle applications, the static pressure from the HRSG can reduce the life of these flex seals. Once the leaf seals begin to degrade, hot gas can start passing through them. That's when you'll notice the telltale signs on the insulation cladding on the exterior of the unit. You'll begin to see discoloration and distortion in the cladding. In many cases, you will not know you have an issue until you begin to see the effects on the cladding, and by that point, there could already be significant damage to the diffuser casing. In this picture, the leaf seals have likely been compromised for long enough for the casing to crack, allowing even more hot gas to escape. Even when you're able to get inside the unit, inspecting the leaf seal area can be tricky, as the damage occurs under the clamping bars. At first glance, the leaf seals on the right seem to be in good condition. This photo shows an internal view of the diffuser trough with the manifold on the top right. The leaf seal bolts can be seen on the ID, and the OD freely moves where you see the rust under the clamping bar. Over time, the leaf seals will become brittle and lose their flexibility. And when the flex seals can no longer flex, you begin to see damage on the OD, as shown here. These leaf seals have been removed from service and would be replaced in kind with new Inco 718 sheets, laser cut to match the existing profile. These photos show how difficult it can be to predict the leaf seal failures, as they could still pass a visual inspection if they were installed in the duct. When hot exhaust gas begins to find a path through the leaf seals, it could be more than just plant personnel safety issues. This gas can cause damage to the diffuser casing, as shown here. This view shows the manifold along the bottom of the picture, extending into the diffuser, which has been marked for repair. To repair this crack, we would cut out the section at 12 o'clock and weld in a new duct piece, and then prep this area for a belt attachment flange to come later. Due to the age of most of your installations, you've probably already done maintenance on the flex seal area a few times. Based on our feedback from customers and what we've seen on our previous installations, we believe that our upgraded flex seal design can greatly reduce the amount of maintenance money and time spent in this area. We do that by replacing the leaf seals just as they were in the OEM installation, but we add a new fabric expansion joint cover on the exterior The new fabric expansion joint cover provides a gas-tight barrier for the leaf seals. So no longer can gas escape through the leaf seal area even during a surge in back pressure. We also increased the size of the ID bolt holes on the manifold side in order to make room for a more robust flange arrangement. If you're already familiar with this upgraded flex seal design, you'll be happy to know that Badger's made significant design improvements to our flanges. We've also improved on our fabric materials, and we've come up with a new idea to insulate the manifold flange to help eliminate some of the hot spots and problem issues that we've seen in some of our lessons learned. Here you can see the fully installed Flex Seal upgrade belt. And what you're looking at in the picture on the right is the ID flange of the manifold, and then what we call the OD flange, the larger diameter of the two, is the diffuser casing attachment. This Flex Seal belt serves as a second line of defense if and when the leaf seals are compromised, and also eliminates the need for external insulation and cladding on the outside of the diffuser casing. As part of the Flex Seal upgrade, Badger offers a turnkey service option with a typical installation of 7 days. If the outage is shorter than 7 days, or there's an emergency outage where you're hoping to get this work done, it could be done quicker, but 7 days is typically the average. Our field service team has performed over 110 of these installations, and as I mentioned before, we believe that the biggest benefit of upgrading the Flex Seal as opposed to just going back with the original OEM leaf seal design is this can put the maintenance of the Flex Seal area out of sight and out of mind, as we expect the average operating life from the installations we have done in the past to be in excess of 12 to 15 years. Also, we're an approved GE vendor for both parts and labor. The next exhaust system solution that we have begins just downstream of the 7FA Flex Seal, and it's the A042 diffuser duct. The A042 is the conical diffuser duct that's internally insulated just downstream of the Flex Seal area and continues to the HRSG inlet joint just before the round to square transition. Beginning at the Flex Seal trough, the internally insulated A042 duct is comprised of batten channels, scallop bars, internal insulation, and stainless liner plates. Of course, the goal in this section is to deliver all the possible BTUs to the HRSG to improve the combined cycle efficiency. But we believe this OEM design can be improved. Some of the first signs of failure that you'll notice in the A042 duct are going to be external hotspots where the paint begins to burn off. You might also see damaged liners during your rounds of inspections. Broken studs can be very common, and after you see damaged liners and broken studs, you may also find loose batten channels. Voids in the insulation can create hot spots, and temporary repairs can create critical issues downstream or in the future. Broken studs can cause loose batten channels. Weld tabs or Z-clips used to secure liners could actually pin the liners in place and not allow thermal growth. This can cause liners to distort or even be pulled out into the flow. Oftentimes, we can also see broken scallop plates or cracked studs. The most common point for failures in the A042 duct is what's called the field joint between the two longer liner plate sections. Highlighted here on the right side, you can see where the two liner sections would overlap. Oftentimes you'll see Z-clips added during maintenance, and those can bind the plates together and prevent thermal growth. The pictures on the right show the field joint with the liner removed. Here you can see the voids in insulation that have happened over time. This can create hot spots on the outside and also clear a path for more insulation to be sucked out into the flow. On either side of the field joint, the longer runs of liner plates are supported by scallop bars and studs. In this portion of the project, you can see that we have cleared off all of the studs, removed all the insulation, and exposed the scallop bars, where you can see some distortions, cracks, and other failure points. Once the scallop bars begin to crack, it can lead to other problems around the liners. The studs can then begin to break off during thermal cycling. Insulation can get pulled out into the flow. And also, if you've ever been walking around the A042 duct on the exterior during your walkdowns, you may hear vibration. Sometimes that can be caused by the scallop bars vibrating against the inside of the liner. Badger's refurbishment process involves the complete removal of the liner plates, the field joint, all of the internal insulation, and the 3/4-inch studs and hardware. You can see on the right-hand side that during the removal of the liners, we actually cut off all of the 3/4-inch studs and original hardware. And on the left side of the picture, our crew is going back in to begin to reinstall what we call our scallop plates with a new stud in order to secure the liner plates back in place. Here you can see the top half of the unit is ready for new insulation. All of the scallop plates have been added, which you can see the threads are all covered by the green thread protectors in the picture on the right. When we come in to replace the studs, it's 100% new studs. We don't want to take any chances with any of the old stainless studs being gulled or stripped. And here you can see the insulation installed before the liner plates go back in. Another photo that's showing the new scallop plates attached to the existing scallop bars, and then again, the after photo of the installation. Replacing the studs is a key area where we feel we can make an improvement on the OEM design. On the OEM scallop bars, the studs were only welded on one side and was a common point of failure and cracks, as you saw from previous pictures. On our refurbishments, we can attach the stud to a stud plate in the Badger shop. Then that allows us to bring that in to the site for an easier and quicker weld onto the scallop bar, and also provides a much more robust weld with less chance of cracking in the future. After all the new studs have been installed and the scallop bars repaired, the liners and batten channels can go back in. Here you'll see that the scaffolding has been removed and the top half of the unit is complete as work continues on the bottom. After all the studs and scallop bars on the bottom have been repaired, insulation can be completed. So to summarize, we have a completed installation on the right-hand side. And a typical installation will usually take about 10 days. And of course, the goals are increasing the thermal efficiency and delivering all those BTUs into the HRSG and not losing heat out through hotspots. Also, it's to take care of all the temporary repairs that have been done over the years, which could end up causing more issues if those Z-clips end up pinning some liners down and preventing any thermal growth. Also a key here is that this work can be done simultaneously with the flex seal and the HRSG inlet joint, which we'll begin talking about next. The HRSG inlet joint can actually be seen here and continues around the circumference as the last point of this duct before you get into the round to square transition. And from the external view, we'll be talking about number 3, the HRSG inlet joint. Though we may call it the HRSG inlet expansion joint, you may have also heard it called the outlet aft expansion joint. It's a cold-to-cold design. It's exposed to UV light and could have UV deterioration over time, and is exposed to the same high temperature exhaust gas flow as the flex seal and the A042 duct. The most common problems to look for when inspecting the HRSG inlet expansion joint are fabric belt failures and also duct hotspots. The OEM belt splice is a common point of failure, and you can see that on the far picture on the right. Also, you can see duct hotspots forming in the upstream and downstream duct before and after the expansion joint. And it'll only be a matter of time before that missing insulation will cause the belt to overheat and degrade. During inspection, make sure to check the fabric belt for discoloration. Also check for hot spots in the duct adjacent to the expansion joint in the upstream and downstream. When we retrofit the HRSG inlet expansion joint, We'll remove the fabric belt and inspect the insulation underneath the flanges. You'll see in this picture on the right, there's a large void of insulation directly underneath the expansion joint flange. This insulation must be repacked in order to keep the belt attachment flange cool and extend the life of the joint. If the insulation is not completely packed underneath the expansion joint flange, it could create hot spots which would further damage the belt. Here on the right, you'll see a completely insulated flange area, and it's now ready for the bolster and then the outer expansion joint replacement. Like all of our fabric expansion joint products in the combined cycle application, the fabric belts have been custom engineered using the highest grade materials possible. Installation of the HRSG inlet expansion joint typically takes 3 to 5 days. And of course, the goals are to repair the hot spots and eliminate any gas leakage, which could decrease the thermal efficiency of the system. Whether it's the HRSG inlet joint, the AO42 duct, or the Flex Seal area, their success all depends on a capable and experienced field service installation crew. And it's our intention to provide turnkey services for this whole area in order to streamline your maintenance process. So your next step is to contact us at your earliest convenience. We will offer a free inspection to come and do a site walk down. We can either do an external walk down while the units are running. We can wait till your next short outage and get inside for an internal inspection. Or we can offer a thorough and detailed engineering report with thermal and standard images. So thank you all for attending. The focus of this presentation has been on the 7FA exhaust system, but I wanted to take a second to let you know we also offer a full range of services for the rest of your plant. Whether you have other turbines at your site, be it Siemens or Mitsubishi, also back to the fabric and metal penetration seals, all the way to the stack inlet joint. So please contact us if you have any needs at all for any expansion joints at your combined cycle facility. Also, we hope to be able to see you as in person as we possibly can. This virtual trade show is going to be interesting for all of us. So we are offering you guys a $250 Amazon gift card as a door prize. So please stop by and register and spend some time with us at our virtual trade show booth. We look forward to seeing you then in a couple weeks. Take care.